Now let's take a look at the following example. In example 1, we want to find the absolute maximum and minimum value of the object functions of the form f of x comma y equal to x squared plus y squared plus 2, where x and y lie on the ellipse C given by the function g of xy equal to x squared plus xy plus y squared minus 4 equal to 0. Let's fill out some important information on the graph of the functions here. So the functions of consideration is of the form x squared plus y squared plus 2, which is a paraboloid. And the function is written as f of xy equal to x squared plus y squared plus 2. So this is the function in brown. The green curves that you see on the xy planes are the level curve. And in this particular context, the level curve that you have is when f of x comma y equal to 10 for this particular value or this particular curve. And for this smaller curve inside the red curve is the level curve of the function f of x comma y when f of x comma y equal to 14 over 3. So this is the level curve when f of x y equal to 14 over 3. Now the red curve is the constraint curve given to us in the form of g of xy equal to x squared plus xy plus y squared minus 4 equal to 0. So here you have constraint curve. That is x squared plus xy plus y squared minus 4 equal to 0. So again, here you can see z equal to 10 is this curve right here projected onto the xy plane. When z equal to 14 over 3, you have this little curve here, and then this gets projected onto the xy plane. And the red curve in here, this is called the function values corresponding to the constraint curve C. So function value corresponding to constraint curve C. And also from this particular curve, we make an observation that at maximum and minimum points, the level curve is tangent to the constraint curve. So here is the maximum point, and here is the minimum points. So maximum points are here, minimum points are here. And again, at maximum and minimum points, the level curve is tangent to the constraint curve. So the observations that we make is the at max and min points, the level curve is tangent to the constraint curve. Now, if we zoom into this level curves and just bring it out here to do with it, as you can see, you have the level curve when f of x comma y equal to 10 on the outside. The smaller green curve is the level curve of the function when the function f of x comma y equal to 14 over 3. So let me quickly note that this is when f of x comma y equal to 14 over 3. The outside curve is when f of x comma y equal to 10. And the blue curves that you see on the figures are the level curves of the functions. So these are the level curves of the function f of x comma y equal to x squared plus y squared plus 2. Again, the red curve is the constraint curve. And it's given as g of x comma y equal to x squared plus xy plus y squared minus 4 equal to 0. And as the observations that we made earlier is that the maximum and minimum values of the function occur at points on C where the level curve is tangent to the constraint curve. So these are the max and mean values. Now our job is to find the absolute maximum and minimum values of the objective functions x squared plus y squared plus 2 with respect to the constraint of x squared plus xy plus y squared minus 4 equal to 0. And again, this is a two-step process. In the first step, you need to find the value of x, y, and lambda if they exist that satisfy the equations that is the gradient of f equal to lambda times gradient of g and g of xy equal to 0. So for the first step, you need to solve for x, y, and lambda, where you have the gradient of f is equal to lambda times the gradient of g, and g of x comma y equal to 0. So you know the function of f, you know the function of g. We're going to find the gradient of each functions as follow. So f of x comma y equal to x squared plus y squared plus 2. Then f sub x is equal to 2x. f sub y is equal to 2y. Now for g of x comma y, you have x squared plus xy plus y squared minus 4. Therefore, g sub x is equal to 2x plus y, and g sub y is equal to x plus 2y. Then you have that the gradient of f equal to lambda times the gradient of g, or 2x comma 2y equal to lambda times 2x plus y comma x plus 2y. And we're going to match each component on both sides of the equations. That is, you have 2x equal to lambda times 2x plus y, and simultaneously we're going to do 2y equal to lambda times x plus 2y. Subject to g of x comma y equal to 0, or x squared plus xy plus y squared minus 4 equal to 0. So I'm going to call this equation equation 1. This is equation 2, and this is equation 3. Now what you do is I'm going to do 1 subtract 2, and this lead me to 2x minus 2y equal to lambda times 2x plus y minus lambda times x plus 2y. On the left hand side, you see 2 is a common factor, so you're going to take 2 out and you're left with x minus y. On the right hand side, you see lambda is a common factor, you take out lambda and you're left with 2x plus y minus x plus 2y. And we're going to simplify this expression inside the parentheses, and we're going to see 2 times x minus y equal to lambda times 2x plus y minus x minus 2y. And I'm going to move everything to one side of the equations. I got 2 times x minus y minus lambda times x minus y equal to 0. And at this point, you recognize that x minus y is a common factor. Therefore, you have x minus y times 2 minus lambda equal to 0, which implies that y equal to x or lambda is equal to 2. So which implies that y is equal to x or lambda is equal to 2. So now that's the first step, that is you find out the relationship between x and y and also the value of lambda, that is lambda equal to 2. Now we're going to move on to the second step, that is we're going to substitute the value that we know into solving for absolute maximum value and absolute minimum value. So in the case that y is equal to x, the constraint equation simplifies to, so the constraint equation is x squared plus xy plus y squared minus 4 equal to 0. In this case, y is equal to x. Therefore, you get x squared plus another x squared minus 4 equal to 0. Or 3x squared minus 4 equal to 0. Or x squared is equal to 4 over 3, which implies that x is equal to plus or minus 2 over root 3. Therefore, two candidates for location of extreme values are, remember in this case, x is equal to y or y is equal to x. So you have 2 points, that is 2 over root 3, comma 2 over root 3, because of x equal to y, and negative 2 over root 3, comma negative 2 over root 3. Next step is to substituting lambda equal to 2 into the equations of 2x equal to lambda times 2x plus y. That is, you have 2x equal to 2 times 2x plus y. If you divide both sides for 2, you get x equal to 2x plus y, or you're going to see that y is equal to negative x. And from here, again, we're going to substitute this relationship into the constraint equations. Then you have that the constraint equations becomes, you have x squared plus xy plus y squared minus 4 equal to 0. But in this case, y is equal to negative x. So you can have x squared plus x times negative x plus negative x altogether squared minus 4 equal to 0. Or you have x squared minus x squared plus x squared minus 4 equal to 0. Or x squared equal to 4, which implies that x is equal to plus or minus 2. And from this value, give two additional points of interest. That is 2, negative 2 and negative 2, 2. So 2 more points. You have 2. When x equal to 2, y equal to negative x. That is y equal to negative of negative 2. And when x equal to negative 2, y is equal to positive 2. So we have 4 different points that we need to use to evaluate the output of the functions. That is, we're going to do f of 2 over root 3, comma 2 over root 3. That is the first point of considerations. We're going to substitute x equal to 2 over square root of 3 and y equal to 2 over square root of 3 into the equations of f. We're going to see 2 over root 3 square plus 2 over root 3 square plus 2. And if we do the calculations correctly, we should get 14 over 3. Now for the second point, you have f of negative 2 over root 3, comma negative 2 over root 3. We're going to do the same thing, that is evaluate the output at negative 2 over root 3 square plus negative 2 over root 3 altogether square plus 2, and this should give you 14 over 3. Now the next point of consideration is 2 comma negative 2. That is f of 2 comma negative 2 give you 2 square plus negative 2 square plus 2, and this is going to give you 10. At the point negative 2 comma 2, you have f of negative 2 comma 2. That is x is equal to negative 2 and y is equal to positive 2, and the output function is also positive 10. From these calculations, we can conclude that the absolute maximum value of f on C for C at the constraint curve is equal to 10. So you have, this is the absolute max value. And the absolute minimum value of f on C is 14 over 3. And that's how you find the absolute maximum and absolute minimum of the function using Lagrange multiplier method.